Reminder, a radian is the ratio of the distance traveled by a point around the edge of the circle to the radius of the circle. Using this definition, we can get a formula for arc length. So what is arc length? Arc length is the distance around the edge of the slice of a circle. So think, how long is the crust on my slice of pizza? So how long is this distance right here? This is your S, your arc length. So the formula for arc length is S equals theta R. Theta is how big is this angle, and R is the radius of the circle. A couple things you need to keep in mind when you're working these problems is theta must be in radians because we're using the radian definition to come up with this formula. S and R are both distances and they must be in the same units, both inches, both feet, both meters. Make sure if one is different, you need to convert it before you can sub it into this formula. And last, the radius is half of the diameter. If I give you any of these problems, like on your take-home tests, then you will have to do one of these three things before you can plug it into this formula. On your homework, it may be straightforward and you can just plug it into the formula without having to do any extra work. All right, let's do 3 examples. Example 1. In a circle with a 10-foot diameter, an arc 20 feet long subtends or forms an angle of how many radians? See diagram. Okay, so we are given that the diameter is 10 feet. We are given that this angle, this arc right here, is 20 feet. And we're looking for theta. Okay, we're going to use S equals theta R. We know that S is 20. We don't know what theta is, and we don't exactly know what radius is, but the diameter is twice the radius, or half of the diameter equals the radius. So usually you put your number before your symbol. So 20 equals 5 times R. They're both in feet. So all I have to do here is divide by 5 on both sides, and I will get that 4 radians is what my angle measurement is. Okay, I went a little fast there, so let's do 2 more examples, hopefully to clarify everything. Example 2. A tire has a diameter of 27.66 inches. Through what angle does it turn while traveling 3 feet? Round to 2 places past the decimal. All right, let's talk about what we know. We're going to use S equals theta R, because that's what all these examples are. A tire has a diameter of 27.66. What piece is that? Okay, well, we know that radius equals half of the diameter, so radius equals half of 27.66. All right, well, what's half of 27.66? Multiply it in your calculator or do it in your head. Either way, you should get 13.83, and we are in inches. Okay, through what angle does it turn? So we don't know what theta is. Through what angle does it turn while traveling 3 feet? So that's the edge of the tire rolls 3 feet. So they're telling you what S is. All right, we're ready to plug in. Or are we? It's really important for you to pay attention to units here. Notice that radius is in inches, but arc is in feet. So we need to make sure they're both in the same measurement. You can either convert 3 feet to 36 inches, which is what most people do because most of us can do that quickly in our head. Or in my notes, that's what I did. In this video, I'm going to convert inches to feet just so that way you can see it in both ways. All right, so 13.83 inches, I'm going to make a T-table. You always start with something in the top left corner. So I want inches to cancel out, which means one needs to be on top, which is what we started with. So I need to put inches on the bottom. I'm trying to go 2 feet. All right, so now think to yourself, how many feet are in an inch? How many inches are in a feet? All right, well, there are 12 inches in 1 foot. And now multiply by every number in the top of your T-table and then divide by each number in the bottom of your T-table. Okay, I have all my pieces. I know S, I know R, I'm trying to find theta. They are all in feet, so I just need to plug into the formula. 3 equals 1.1525 times theta. So divide my 1.1525 over to the other side. And type that into your calculator. You get 2.60. And if you check my notes online, you'll see that I also got 2.60 even though I converted feet to inches. All right, last example. Shauna is about to perform a relay handoff on a circular track that has a radius of 18 meters. Her track partner is standing 67 degrees away from her. How far is Shauna from her partner? All right, let's talk about what we know. Shauna is about to perform a relay handoff on a circular track that has a radius of 18 meters. Okay, good. They already straight up tell us what the radius is. Her track partner is standing 67 degrees away, so that's my theta. How far is Shauna from her partner? So we are looking for arc length. All right. Remember, I told you, I am not going to straightforward give you anything of this type on your test. So you will either need to be converting units for S and R, converting radius, or converting angle measurement. Or you could do all three of those, or just two of those, like we did in the last example. We had to convert units, and I think we had to come up with the radius. So just know you have to do at least one of these whenever I give you a problem. All right, we don't have to worry about S and R right now because we don't know what S is. They straight up gave us the radius, so we don't have to worry about that. But these have to be in radians. A lot of times I call these radian word problems to remind you that your theta has to be in radians. So convert to radians. I am going to use the rounded version because in real life, I don't care about things having a pi in them. Here we go. So 1.169. And now I can sub it into the formula S equals theta R because now I know what theta is. So S equals 1.169 radians times 18 meters, and we get 21.05 meters. Make sure you include units because these are all word problems, and also including units will help you keep in mind that you need to check your units. Make sure theta is in radians. Make sure R and S are the same unit.